Imagine the vastness of space, billions of galaxies, trillions upon trillions of stars. Data is the new frontier, a boundless cosmos of information. Much of this data is unlabeled, like distant stars waiting to be categorized. Unsupervised learning helps us explore this uncharted territory, discovering hidden structures and relationships. In machine learning, two approaches reign: supervised and unsupervised learning. Supervised learning is like learning with a teacher. We provide labeled data. The algorithm learns and predicts outcomes. Unsupervised learning is like learning without a guide. The algorithm finds patterns and relationships on its own. Imagine classifying celestial objects. Supervised learning uses labeled examples. The algorithm learns and classifies new objects. Unsupervised learning groups objects by inherent characteristics. Both approaches are powerful tools. Clustering is a fundamental technique in unsupervised learning. It's the art of grouping similar objects together. Think of stars forming clusters in the vastness of space. Clustering algorithms find natural groupings in data based on shared characteristics. Imagine analyzing customer data. We have information about their purchases, browsing history, and demographics. Clustering algorithms can group customers with similar behaviors together. This segmentation is invaluable for targeted marketing and personalized recommendations. How does clustering work? It's like mapping a constellation. We plot each data point in a multi-dimensional space. Each dimension represents a different feature or attribute. Clustering algorithms then group nearby data points together, forming distinct clusters. These clusters reveal hidden patterns and relationships. They help us understand the underlying structure of the data, even when it's unlabeled. Section 4. Applications of unsupervised learning, from customer insights to anomaly detection. The applications of unsupervised learning are vast and ever-expanding. Like telescopes revealing distant galaxies, these techniques provide insights into a wide range of fields. Customer segmentation is a prime example. By grouping customers with similar behaviors, businesses can tailor their marketing campaigns, personalize recommendations, and improve customer satisfaction. Anomaly detection is another crucial application. Unsupervised learning algorithms can identify unusual patterns in data, flagging potential fraud, system errors, or medical abnormalities. It's like searching for a rogue star, something that deviates from the norm. Unsupervised learning is also used in image recognition, natural language processing, and drug discovery. Its ability to find patterns in unlabeled data makes it an invaluable tool for scientific discovery and technological advancement. Section 5. Unsupervised learning algorithms, K-means and PCA. Numerous algorithms power unsupervised learning. Two prominent examples are K-means clustering and principal component analysis, or PCA. K-means clustering is like grouping stars into constellations. We specify the desired number of clusters, or K. The algorithm then iteratively assigns data points to the nearest cluster center, refining the clusters until they stabilize. PCA is a dimensionality reduction technique. It's like projecting a three-dimensional object onto a two-dimensional surface. PCA finds the principal components of data, which are new variables that capture the most variance. This reduces the complexity of the data while preserving its essential information. These algorithms, along with others, provide a powerful toolkit for exploring unlabeled data. They allow us to uncover hidden structures, identify anomalies, and gain insights that would otherwise remain hidden. Section 6. Conclusion: embracing the unknown in the vast realm of data. Unsupervised learning is a journey into the unknown. It's about exploring the vast cosmos of unlabeled data, guided by the patterns and relationships that emerge. Like astronomers mapping the night sky, we use these techniques to unveil hidden structures, identify anomalies, and gain a deeper understanding of the world around us. The universe of data is constantly expanding. As we gather more information, unsupervised learning becomes increasingly important. It allows us to navigate this complex landscape, to find meaning in the chaos, and to unlock the potential of data that would otherwise remain untapped. By embracing the unknown, by venturing into the realm of unlabeled data, we embark on a journey of discovery, Fueled by the power of unsupervised learning, the insights we gain have the potential to transform industries, advance scientific knowledge, and shape the future in profound ways.